Projection of a pentagonal plane. In this tutorial, we'll explore how to accurately depict the projection of a pentagonal plane inclined in both the horizontal plane and the vertical plane. Let's dive into an example. Draw the projections of a regular pentagon of 50 mm side, having its surface inclined at 40 degrees to HP and a side parallel to HP, and inclined at an angle of 50 degrees to the VP. Let's understand this visually in a three-dimensional view. The question states a pentagon with a 50 mm side, its surface inclined at 40 degrees to the horizontal plane, and one of its sides parallel to the HP. We can see in this 3D view how the pentagon will appear. Now, the surface of the same plane is angled at 50 degrees with the vertical plane. This demonstrates how the plane is positioned within the three-dimensional view. Now let's draw the projections in a two-dimensional view. Steps in the drawing. 1. Drawing the true shape of the and true length of the shape. 2. Inclining the plane to HP. 3. Inclining the plane to VP. This line, labeled as XY, serves as our reference line. In step 1, when drawing the true shape of the plane, the first task is to determine its placement. As indicated in the question, the surface is inclined to the horizontal plane, indicating that the true shape of the pentagon will reside on the HP, below the XY reference line. Once we've established where to draw the pentagon, the next consideration is its orientation. There are two possible orientations, one with a side perpendicular to the reference line, or with a corner at a line perpendicular to the reference line. Examining the question, we note the mention of a side parallel to the HP. This indicates that we should draw the pentagon in this orientation. If the scenario had described a point resting on the HP, we would have drawn the pentagon in this orientation. I hope this clarification resolves any initial uncertainties regarding where to draw the true shape and its orientation. Let's begin by drawing the pentagon. Grab a ruler and draw a vertical line 50 mm long below the reference line. Then, using a protractor, mark a point at a 108-degree angle from each endpoint of this line. Connect these points to form the sides of the pentagon. After this, using a compass set to a radius of 50 mm, place the compass's center on each of these endpoints and draw arcs to complete the pentagon's true shape. Label the corners of the pentagon accordingly. Next, we need to obtain the front view of the pentagon. To do this, project lines from each corner of the pentagon as illustrated. Draw a horizontal line on the reference line. Front view of the pentagon is on this line due to no mention of the plane being above the HP at any distance. Since one side is parallel to the HP, it indicates that the side is resting on the HP. This gives us the front view of the pentagon. Proceed to label the points as follows: A dash, B dash, C dash, D dash, and E dash. Next, we will move on to step number 2, which is to incline the plane at 40 degrees to horizontal. To do so, we will first incline the front view of the plane at 40 degrees, and using its projections we will draw its top view below the reference line. Mark a point on the reference line, designating it as A dash, E dash. Using a protractor, mark a point at a 40-degree angle from this reference point, and draw a line connecting these 2 points to establish the inclination. Next, adjust the compass to the length of the front view and cut an arc, resulting in the point C dash. Then, measure the distance between these 2 points and mark it as shown, determining points B dash and D dash. This completes the front view of the plane when inclined to the HP. To draw the top view, project lines from each of the points as indicated. Then, project horizontal lines from the true shape of the pentagon. The intersection of these lines will provide us with new points, enabling the drawing of the top view of the inclined plane. The intersection of line A-E- with horizontal line A gives point A. Similarly, the intersection of these lines gives point E. These intersections also provide points B and D respectively, while the intersection of these lines gives point C. By joining these points, we will obtain the top view of the pentagon inclined at a 40-degree angle with the horizontal plane. This completes step 2 of the process. Now, we can proceed to the final step, which involves inclining the plane that is already inclined with the horizontal plane towards the vertical plane. To accomplish this, we'll rotate the top view of the pentagon by 50 degrees, as specified in the question. To do this, we'll select a point on the reference line and draw a line inclined at 50 degrees with the reference line. Then, we'll draw the pentagon on this inclined line. Mark a point on this line, designating it as point A. Subsequently, take a compass adjusted to the length between points A and E, and using point A as the center, cut an arc on the inclined line. This will determine the position of point E. Now, adjust the compass to the distance between points A and C, and cut an arc using point A as the center. Then, adjust it to the length between points E and C, which will be the same. Using point E as the center, cut an arc as shown, establishing the position of point C. Afterwards, adjust the compass to the length between points C and D. Since the distance between points C and B is also the same, use point C as the center to cut an arc as indicated. Finally, adjust the compass to this length, and using points A and E as centers, cut the arcs as shown. This process determines all the required points of the pentagon. Join these points to obtain the top view of the pentagon inclined at both the HP and VP. In the final step, we'll draw the front view of this inclined plane. To achieve this, project vertical lines upwards from all the previously determined points as illustrated. Next, project horizontal lines from these points in the front view. The intersection of these lines will give us point A dash. These lines will determine point B dash, while others will identify points D dash, C dash, and E dash. Connect all these points to obtain the front view of the pentagon inclined to both the HP and VP. This completes the process of drawing the plane inclined to both the HP and VP. I trust this video has provided clarity on how to draw a plane inclined to both the HP and VP. This same principle can be applied to all other shapes as well.